Shannon, thank you so much. And Jared, a great lead into this. Again, the idea here is we're going to talk about data modeling, but we're going to talk about it in a way that maybe hasn't occurred to you yet. And hopefully, as a result of this, you guys will give us some feedback and we'll all learn more. So again, you know my style. I do a whole bunch of things. Let's get it really going and give you a bunch of stuff that you can come back and reference later on. So we're going to talk today starting off by looking at what data maps and models are. And the piece that Jared just referenced there, having to have all of that come to a single hub, unifying the message, unifying the tool set, all of these things are wonderful ways to do this. At the heart of this, of course, is the data model. So we'll get started there, then we'll look at architecture and engineering, and I'll look specifically at looking at it from the top down, the bottom up, and then how the two of them work together. About an hour from now, or a little bit less than that, 50 minutes. Jared will come back online and we'll get some questions from you guys because that's really the fun part of this. To get us started here, I knew Dr. Fred Brooks. He passed away a couple of years back, but he had some really great things to say about IT in general and software engineering in particular that are still highly relevant today. The first one was something called the Mythical Man Month, which is sort of obvious to everybody, but we don't actually teach it in school, which is to say that 9 people working together for 1 month apiece cannot produce a baby, right? There's just no way that some of those things are fungible. But more importantly, he also said data is the essence, data representation is the essence of the programming. And that really can be taken as the message here today. Show me your flow chart, he said, and conceal your tables, and I'll continue to be mystified. But show me your tables, and I won't usually need your flow charts because it will be obvious. And that's really kind of a fun thing about what we do in the data world. We can look at what your data maps look like and tell you a whole lot about your organization as a result. Now, those of you that are not familiar contextually, we're looking in this portion, for this portion of the program, of the DIMBOK wheel. This is the data modeling practice area, and it focuses on analysis, database design, implementation, and other types of data development, as Jared was just talking about. And I'm going to jump right in and start to talk a little bit about AI. I happen to be a Gemini fan on this. And Gemini actually has a facility called GEMS, and think of it as sort of agent-like. What it does, you can tell this particular gem here that I want it to be a data modeling expert, and I want it to respond as a seasoned data modeler. You're excellent at illustrating how your data models are useful and all the rest of the things. I tell it to don't break character, and you can tell it to use particular sources and things if you have that type of thing. And all of a sudden, you have a really nice data piece. So one of the first questions I asked up here in the upper right-hand corner, where can I find a candidate data model for a pharmacy? And Shannon, you'll get a kick out of this one as well. It comes back immediately and says the gold standard for pharmacy models comes out of a book by Len Silverstone from a couple of years ago. If you haven't had a chance to see it, it's Universal Data Models. I would recommend buying all 3 of those volumes because they come with a CD at the back, and that, if you remember what a CD is, it actually has the models in Irwin format. Makes it very nice and easy to use. And the reason we need all this, of course, is because we've had this incredible disparity between the growth in data and our ability to do the analyst role in here. You can see they're growing at exponential rates in this case. And what that means is that we've got to come along and get everybody on the same sheet of paper. The first place to get on the same sheet of paper is a business glossary. We've had lots of names for it over the years, encyclopedia, data bank, all sorts of things. But it really is a necessary prerequisite to any meaningful integration. It helps you to start developing your enterprise taxonomy. In fact, the AIs are pretty good about finding existing taxonomies and mapping your stuff to it. You may not want them to do that, so don't immediately take the answer. Just as with everything else in AI, handle it with care. It talks specifically about what the initial entities for the conceptual data model probably should be, and it engages the business community in order to dive these things back and forth. So you need to have a trusted catalog in order to do this. You can build one with a single web page. If you can't figure that one out, hit us up with the questions at the end and we'll get up to it. Because what you're trying to do by understanding data is making sure that you have a digital blueprint showing the interconnections and commonalities among specific entity and attribute combinations that links the business users, the technical people, and the systems as well. Critically important to do that. So let's look at data models. Data models capture and maintain the formal, usually physical system data requirements. It's a purposeful structure regarded as a whole and consisting of interrelated, interdependent elements. In other words, from systems thinking, you have the parts all together. That's the scope of your data model. When you look at it that way, it represents the most granular level of systems decomposition that can be achieved. And when we look at systems, we think of systems as being composed of people, process, hardware, software, and data. But I can tell you over time, the data has been the most stable component of any of these systems. And that's based on 40 years of experience, much less the fact that everybody who taught me exactly the same lesson around in there in order to figure it out. The problem is that data is oftentimes subsumed by software. It's overlooked. Oh, we're buying this, it's going in the cloud, or we're going to buy Salesforce. Again, really good software, but the data portion of it doesn't get as much love as the apps do in order to do this. The key with all of this, of course, is that you want to start incorporating the business rules in there. For example, a very simple one that I actually have a longer story about, again, hit me later on at some point. Can a project be owned by more than one department? Might be a very reasonable question. If it isn't correct at the data model representation, then all of the other representations, interpretations must be suspect. And this actual question, can a project be owned by more than one department, caused a fight at one of the large companies in there because they didn't believe that it should be, but nevertheless, the database was set up so that it could be, and therefore that was the rule in order to do this. Data has some really unique properties. That was about as good as I could come up with for an abstract on this. And I do want to acknowledge Doug Laney's wonderful book, Infonomics, where I pulled a couple of these things from. But first key is that data is not really visible. Certainly with visualization and things we can do better. It's non-rival, which means the cost of providing an additional copy is oftentimes close to zero. It does not require replenishment. It is nearly unlimited and regenerative. It has low inventory and transportation costs. It's more difficult to own and control. And if you mess it up, it's really hard to clean up. So we'll take our data modeling and say that data modeling is the process of discovering, analyzing, and scoping data requirements. We're trying to answer some specific questions that are relevant to your project. Representing and communicating the requirements in a precise form. These are maps of critical business assets, and that they compose and contain metadata that is essential to the data consumers, functioning as a kind of sheet music for all of us, and that metadata is essential to other functions in there, and that the process is iterative into the process. We're going to dive into these in a little bit more detail. So the first one is discovering, analyzing, and scoping data requirements. And this is just the case that we need to have what the organizational lists of persons, places, things that need to be created, read, update, or deleted. In other words, if there's something we're going to create, read, update, and delete about, and it probably falls into a person, place, or thing category, it probably should be in your data model. These are called, of course, attributes, and the attributes are the characteristics of certain things. Still keeping on that same thing, an organization might decide to characterize a thing as having a thing ID, a thing description, a thing status, a thing sex to be assigned, and a thing reason reservation. Each of you give us specific consequences on this. For example, whatever the thing is, there is a female version of it that we can have just based on this particular data model, or the contrary piece. If you need to have female things or exclusively male things, whatever they happen to be, and you don't specify them in your data model, they will not be able to be done that way in the real world. All things in this case have a status, and many things can be assigned to a female in this case. And again, the ID permits every distinct thing to be distinct from every other thing. The description is also likely to be unique for each thing that we're looking at in there. So that's the process of discovering, analyzing, and scoping. Let's now communicate. Again, representing and communicating this. And it's just a little awkward. The English language isn't the best on this, but it represents both the process of doing the analysis and the result of that analysis. So here I have thing one and thing two, and I'm saying that there is a connection between them. That means that every thing one must be accompanied by a thing too. And more importantly, we're unable to store information about that thing until we have information about both things. Same is true for deleting. You can't delete one thing without deleting the other thing at the same time. And you might say to yourself, this sounds kind of crazy, but it actually does happen quite often in the real world where people are looking at these. And each of these then represents some level of granularity, defining optional or mandatory relationships and the minimum and maximum occurrences around each one of them. So our notation is very, very concise in terms of representing these maps of critical process. The whole thing is, of course, iterative. The organizational needs are what start out. These become instantiated and integrated into data models that then authorize and articulate its specific requirements for the system, and the cycle repeats. And it doesn't stop repeating until you don't need to do any more evolving of your organization. Data models are developed in response to specific requirements. And as I said before, the process is iterative because once again, I have this trusted catalog. I can now start to make that catalog better, faster, cheaper, less risky, all the way around as we get better at the process and continue to feed the data dictionary that we have in place in order to do this. Get back to our sort of mini theme slide on this. Let's take one more. That is the idea that there are definitely three levels of data models that most people talk about. There's, in this case, a conceptual view that allows independent customized user views. So the users only see conceptually what's there. The logical view actually gets into a more specific business context around here and will be more elaboration, starting to talk about what would be primary keys and things. And then the physical model itself, of course, is the other part. These have been standardized by ANSI for many, many years. Unfortunately, it's not taught very well, and so students are kind of confused on this, but those of you that have been in the business should be nodding your heads and going, yep, got that. Again, the idea here is that we can insulate the users if we decide to take out one database at the physical level and put in another one because of this layering, the same way that we use layering in the OSI protocol when we're dealing with communications. Each data arrangement is a data structure, and you can see some of the characteristics. There's a grammar for the objects that'll be in there, and the constraints. They could be in sequential order, they could be unique, they could have some sort of relationship that's hierarchical, network, lakes, otherwise types of things in here. But what you really end up with is the situation where you're trying as hard as you can to get all of these things together. The organization that puts all of these together should go for as few of these as possible. And in fact, if you're wondering how you can make a contribution to your organization, it is by eliminating usually multiple redundant types of data structures because it only causes confusion in there. Once again, hit us at the questions. We'll dive into that a little bit more detail. Another thing that's really important about the entire process is to make certain that you don't use what is called a standard definition. And I'll show you the AI is actually ahead of us in the areas. So for example, here is a definition of a bed that somebody used on a government project that I was associated with many moons ago. The bed's a piece of furniture which is used as a place to sleep or relax, unless you're talking about a hospital bed, right? And in which case you might have a very definite relationship. So let's just start and do a little data modeling. What's the proper relationship between these two entities, bed and room? Well, we might start here and say that beds are clearly related to room. That's a good start. We can be even more precise with that. We can say that in this case, many beds are related to many rooms. That's not as precise as we'd like to get it. In fact, we look a little bit further in how the organization actually does this, and we'll discover that one room can contain 0, 1, or more beds that are associated with it. Once again, we're diving down in much more detail here and being much more precise about it, which means that each bed can only appear in one room at any one point in time. Just a quick side note on here. Again, the idea, oh yes, that's right. What happens if bed can be moved, right? That's a problem as well. Again, we have some cardinality relationships here. I'm just putting them up on the board. You'll have the slides, so of course you can look at them later on. But there have been over the years different variants of doing different modeling type notations. There's an information style, there's a Chen style, a Bachman style, a Martin style. None of them are wrong. They all convey the same information. Pick one. Most people have been going these days with information engineering style, but nothing wrong in terms of all that. So what's a relationship then? Well, natural association between the entities. Here's the rooms, the beds, and the patients. And again, you can see we've taken the beds and put 0 or more beds can be associated with a room. That even also represents a refinement, because the way I had it before, a bed shall contain at least one room, is not necessarily true. A room could contain 0 beds. So again, we can do this. A bed is placed in one and only one room, and a room contains 0 or more beds. A bed is occupied by 0 or more patients. That one sounds interesting. And a patient occupies at least one or more beds. Well, again, these may not be the rules that you want to get into, but it does help us do better. Like I said, if you put bed as something you sleep in, you miss out on the intention. I like to say that you really need a purpose statement. And a purpose statement incorporates motivation as well. So you can see here for this particular exercise, it was part of one of the military health systems, is a substructure within a room structure of the facility location. It contains information about beds within rooms. Great, no problem. But we discovered that these guys were actually going to put an RFID on the bed and decide that they could locate the bed anywhere in the hospital. Now, this was before GPS, so all you had was RFIDs, which were responsive but not nearly as precise, and certainly not tracked to a geocode. One of the questions that came up was, well, what room is the elevator and what room is the hallway? Showing that they had not really thought through all of the characteristics that they needed to do in order to do that particular exercise. Now, I went to my local chat GPT and said, hey, oh, yes, I'm sorry, I'm going to add one more piece there. All of your models, all of your data models start out as draft mode. And only when they're validated do you turn them to valid, because only when they're validated do you have actually good information. So this is Gemini again here. I said, please write me a definition statement for the entity bed. I won't read it to you, but you can see here it's kind of important because the AI has already figured out that you shouldn't just use a definition. Notice here what happens. When was the motor on bed 4B last serviced, right? Without disrupting the broader room level data that's in there. I asked it for a purpose statement as far as AI is concerned. They're both the same, but you get the context in here. When you're doing this in a healthcare situation, bed represents a source of revenue and something that needs to be managed extremely carefully as you go through this process. One of the other things that's important to understand about all this too is that if we fix things at the data model level, they are cheaper than if we catch the errors later on. And the best way to represent that is something comes from the manufacturing industry, where they have a 1, 10, and 100 rule. And the idea is that when you start out, if you fix it at the source, it costs you $1, but if it gets to the warehouse, it costs $10. And if it gets into production, it costs $100 to fix. So most people are very aware of that. And if you don't, go to your manufacturing people, they'll help you understand that. In many ways, then, the data model is very much like the Princess on the Pea story from Hans Christian Andersen. You'll notice the pea is at the bottom of a large number of mattresses, and the princess is still sleepless up here on the top. The key, of course, is that when we move into these things and try to work at it, failure to understand the role of data locks in these imperfections for life. It restricts the investment benefits and decreases our organizational ability to leverage data. 20 to 40% of your IT budgets are spent evolving data, migrating it, converting it, and improving it. And this leads to, unfortunately, something that most people are not really aware of. It's called data debt. And I'm obviously showing a data debt situation here, but you can see there's all kinds of drags it puts in place. And most importantly, 80% of your organizational data is redundant, obsolete, or trivial. So we've got to get past those two particular areas. I asked again Gemini to say, what can you do about aiding AI using AI to aid data modeling. Again, natural language to schemas. Yes, you can feed a generative AI with this description that said we need to track prescriptions, the doctors who wrote them, the patients, and it will come up with suggested entities that come up and produces an actual model for you. Once again, AI is not 100%. It's about a B student, about an 85. But as long as you do this, you can do some really good things with it. It's a great leverage uh, uh, for doing this sort of thing. You can do intelligent and semantic mapping in here. And again, using these to understand that RX number is the same one as prescription ID, even if the names don't match. It can pick this up contextually. On this third component is automated documentation and metadata generation. Nobody likes to do documentation, but AI does it really well. And finally, predictive what if modeling. Now, by the way that you motivate people in these areas is by saying to them, go out and break this. There's an AI that did it. We don't trust it. Go out and try to break it. If you pay people to break it, they will find the errors and you'll have a much better product. If you just assume that the AI has done it correctly, you are in for a rude supply, unfortunately. So let's talk about architectures and engineering now. Again, different portion of our Dimbach wheel here, but looking at enterprise integration, IT procurement and planning, value chain analysis, and enhancing communication all the way around this. Reminds me of a very, very smart, very capable CIO who I worked with for a number of years who never understood the data piece. He said, but I don't understand it. I see that when my people are using your maps that you create in Hong Kong and in Tokyo, that there's a useful product coming out of there, and I don't need to know about it. I just need to know that they need to do it, and therefore we need to have these things modeled in the correct way to do it. In today's environment, you're probably dealing with hopefully only one cloud app, but some organizations are having to deal with multiple cloud apps, and then maybe some stuff on premises as well. The organization's data models are the only thing that maps across these applications into and out of the cloud, and more often than not can be used to find our data correct source of information in order to do this. A favorite book of mine in this area that's available on the Kindle subscription package, so you don't have to pay for it. Abby Covert wrote a book called How to Make Sense Out of Any Mess, and starts off with a really great example. Imagine, first of all, that you're asked to make the case that organized data is worth more than not organized data. So I want you to take her book on there that you buy. Pretend you've got a hard copy of it instead of a PDF version of it. Take the back, the spine off of that book, and hand those pages out to all of your colleagues without page numbers on them. It's very hard to make anything understand this. And yet, when we look at what's on organizations, how they have to operate in order to run these things, data architectures are here whether you like them or not. All organizations have data architectures. The only question is, do you understand it? And if it's not documented, it means it's in somebody's head. So let's look at architecture for just a little bit. Again, most people look at a software engineering effort, so they're looking at a single program. If we have two, three, all programming off the same thing, I'll call it a family of programs, we might have some things there. ERPs and commercial off-the-shelf software packages are typically marketed as being similarly integrated. But if we do the data modeling of that whole thing, we get all three of those, or 10 if there happen to be 10 in that family, and they all come together in order to do this, which then we have a green family and an orange family over here, and we still need to sort of figure it all out. Well, data architecture has a broader focus than either the software or the database pieces, and it's talking about looking at the system-wide use of the data and the challenges, addressing the challenges that are caused by data interchange or interface problems. The architectural goals are always going to be more strategic than operational. So if we are in a typical organization where we have an unknown number of applications, we start out by counting them. If we only had 6 that were here, that would leave us a worst case upward theoretical complexity of 15 interfaces that would be there. And I actually asked the Royal Bank of Canada to be able to use theirs. That one time they had 200 applications with about 5,000 batch interfaces. That's a lot of complexity to measure. And that's exactly what Jared was talking about by putting something at the center of it and simplifying your existing environment. Levels of abstraction, again, architecture is up, models are down. This is what we want to talk about. We don't talk about a piece of wood with a piece of brass attached to it and perhaps a piece of glass in it. We talk about a door. Again, these are important abilities to be more efficient about our communication all the way around. It's important also to look at the relationship here between architecture and engineering. Architecture is used to create and build systems too complex to be treated by engineering analysis alone, whereas the engineers develop the technical designs for implementation, and they are typically supervised by other specialist disciplines. Well, in our modeling context here, we have the same kinds of things. The models comprise any architecture, and all architectures require models in order to do that in here. And if we look at the relationship between data architectures, all data architectures require data models in order to do this. However, it is important that you have qualified people that are able to do this. I've found this particular little short snippet to be one of the most effective, and you're welcome to clip this off of here, off of the recording of this, but it clearly shows that you can't architect after implementation. Once we started building the Empire State Building, the Taj Mahal, the pyramids of Egypt, the Arch of St. Louis, there's no way we can come back and change those aspects as we look at this. And again, leaving us with, how on earth did they do all of these crazy sort of things? That's an architecture piece. Here's an engineering, one of my favorite objects in the entire world. I'll give you some attributes about the object. It is taller than I am. It has a clutch. It was built in 1942 and it's cemented to the floor. Well, what on earth are we doing? We're trying to feed 4,000 soldiers every day on the USS Midway during a battle, during a war that we didn't know how long the war was going to last. And there's no way that we could have replaced the functionality of that mixer with this smaller mixer, even though it is a good quality mixer. If you make pancakes with 4,000 people in one day, I guarantee you that little red thing is not going to be usable after that. So you might ask, how are these data structures supporting strategy? And the first thing to do is to ask the opposite question. Were your systems explicitly designed to be integrated or otherwise work together? Again, some CRMs, some ERPs, some commercial software products are in fact doing this. All of them claim to be. So you can get the nuance there. And if they weren't designed that way, what's the likelihood they'll just happen to work together? We can't have any useful information taking place as long as their strategy is unknown. There's two answers and two separate strategies. One is achieving effectiveness goals. The other is looking at dexterity in that. Again, if the plates up on the top half of that picture there are required because you have a different bowl to serve your peach cobbler than you do to serve your apple pie, that's going to be more expensive to fix when you have an error than if everybody uses the same plate and we just grab the next plate off the stash. Frameworks are a foundational form of collaboration in here. And when we look at the little pieces that are in here, the details are organized into larger components, and that becomes a fairly intricate process. Larger components are organized into models, and that's where we get into the need to understand dependencies, like I can't put an order against something if I don't have the initial order in the first place, a purchase order, for example, or something. And finally, models are organized into architectures composed of architectural components, and this gives us purposefulness. All architectures have to have some purposefulness. We can make the same architecture do different things, but not as well as if we create a separate architecture for fast versus a different architecture for quality. Not that the two are mutually exclusive, but again, they do come into here. So keep moving. Again, architects organized into entities into objects. That takes care of our dependencies, and the models into architectures. A question that you might ask is, why don't we see more of these things? And the answer is, well, it's kind of hard to tell actually what it is, and certainly not in a PDF form. In fact, I'm not even sure which way it goes up. There we go. Now I finally got it in the right area, and that isn't helpful to you at all. Let's look at a couple things here. Again, data architecture determines interoperability, but the data architectures capture the meaning of the data that's in there. So again, ask a question. How can AI help data architects? Once again, we get a real good piece. The death of the blank page modeling. Everybody knows if I have a blank piece of paper in front of me, oh my gosh, it's scary, right? Two, we can do this automatic schema mapping and semantic harmonization, and it's very, very productive. You can do predictive performance of an architecture. Again, if we try to throw a production workload on this, we can simulate it and come up with some very good initial prerequisite without having to build it in order to do that. And finally, governance and compliance can be done at scale. So as a seasoned architectural perspective, the AI builds the structure, but you as the architect provide the vision. So we're going to look at both of these now working together. From the top, it's really a forward engineering, the goal of building something new. I like to call this my washing machine model. You'll see this in just a second, but I'm going to tell you all of the various types of models that can exist within your architecture. The first one is an as-is model. That is the existing system, how it looks today. The other is a to-be system. That's how you'd like it to look. And remember my little point there about validated and unvalidated before. All models that are unvalidated are suspect, and you're running a risk if you're doing that. So that's the second way. First is as is to be. The second is validated, not validated. The third one takes that conceptual, logical, and physical layer that we talked about before and adds to it. And most importantly, on all of this, every modeling change can be mapped to a transformation in this framework, which is really nice because it means the AI itself is rather constrained about what it can do, what it wants to do, and what it understands. The opportunity for it to make mistakes is lessened, not eliminated, but lessened. So let's start out here with a forward engineering example, which is, of course, what we teach people. Now, don't ask me why. We teach them how to build new stuff, but they spend 80% of their time enhancing existing stuff. But okay, we start off with our conceptual model, we go to a logical, then we go to physical, and at each layer you can ask whether this is being done correctly. What do I mean by correctly? Well, there are correct ways to organize data. It can be organized, remember I said the strategies before, and there are lots of different techniques that we can put in place. I'm sure I don't have all of them here, but let's just take a couple
It suggests
examples.
naturally a watchful feminine presence at a switchboard.
I
And the
just couldn't resist
supplementary
playing that little
agency that in a few
piece in
seconds
there.
can
Saying that all females have to be, excuse me, all phone operators have to be females back in our old way of thinking. And in fact, the reason we went to a digital system at all was because they discovered that if we weren't careful, we would have every female in the United States of America being employed as a phone operator to make phone calls for us. Here's another example right here, too. Course listings. This is my course listing of my courses here at my university that we had a couple of years ago, and they were coded. Every B36 number meant that we were doing a business computer course, but we couldn't add another course because we'd run out of numbers. Well, that's not what you want a dean to say, is to stop doing things. Or let's take a relatively large package delivery organization that I'm familiar with and have worked with in the past. They've discovered that they need to expand their master data item customer number by 2 digits from 14 digits to 16 digits, requiring upwards of 100,000 changes to be managed. These are incredible complexity numbers in here, and they're things that we have to be careful of. Again, let's look for ways in which we can do this. So here's our tables in here, and here is something from, in this case, it's called the iTunes or music database that exists on the Macintosh computers. The same model is implemented in most of the Windows machines here as well. So you'll notice I have included a Oscar Peterson album here, a real favorite of mine that was recorded in Helsinki, and it pulls in some data. It pulls in the song, the album, and the length. But it doesn't actually produce the length. It produces a start and stop time, which is more flexible and less risky, kind of like storing your birth date, not as a date, but as your difference between the current time and where you were actually born around that. All right, so let's take this typical sort of piece here. Again, like I said, from the music database, and I'm going to put 4 columns in place: record, purchaser ID, song, and price. Now, what information would be lost if I deleted record number one? Well, the answer is if I lost record number one, I would lose not only the fact that purchaser number one purchased Cool Walk Live, but I would also lose the fact that Cool Walk Live costs 99 cents. That is usually undesirable and unintended. Second type of anomaly here, again, is an insertion anomaly. If I want to add a new song called Cakewalk Live and it costs $1.29, with this structure, I cannot add it to this table until I have both a purchaser and the fact that Cakewalk Live costs $1.29. That is 2 facts in there. We don't want to do that. Finally, we have update anomalies that we can put in place. And again, I'm giving these to you so you can use them as real easy illustrations. So here's our song here now. I want to change the price of Cool Walk Live from $1.99 to $1.29. Somehow it didn't pass our quality control piece. Well, in order to do that with this table, I'm going to have to look at every song in the entire database and find out whether or not it is Cool Walk Live and then change the price. That assumes that Cool Walk Live is spelled correctly each place along the way. Again, it could be really problematic if somebody key punched it incorrectly. And we have seen people have problems with that. So I'm going to take that database that I just showed you, and I'm going to tell Gemini that the database consists of the following rows: ID, purchaser, song, and price. Is this table normalized is the question. Of course, it gives me a little pat on the shoulder and says, yep, hey, good for you for thinking about normalization. Now, the sycophancy is endearing, I guess, but it does, in fact, talk about these things. And notice it got exactly the same information that I had about redundancy anomalies and deletion anomalies in here, and tells you what the steps to do it and how you should go through and do it. A little bit, again, very good information coming from here. How can AI help data modelers with the forward engineering projects? Well, we can talk about the requirements to the draft logical models. We typically spend weeks in discovery sessions, and we're going to be able to move from a blank canvas to half complete in just a number of hours, as opposed to weeks that we used to spend doing this. You can look at intelligent physical transformations. If you remember the old case tools, it knew the difference between an Oracle database and a schema from another company or another thing. You can automate the DDL and script generation. Again, case tools did this, but it's still okay that it can do it. You don't have to buy a case tool in order to look at that. And finally, we can look at specific impacts by rapidly prototyping, lowering the technical debt, or data debt, as I called it in there. And again, platform portability. So if we want to re-platform something, we can get to something else fairly easily. Again, the AI provides the what, but we provide the why. And that's a wonderful division of labor. So that was from the top. Let's look at it from the bottom up. This is reverse engineering, the area where I started out my career. Again, remember, 80% of the work in this area is done with some form of reverse engineering. It has a technical definition from my friend Elliot Tchaikovsky and James Cross: evolve existing systems using a structured technique aimed at recovering rigorous knowledge of the existing system to leverage enhancement efforts. It's an IEEE standard wonderfully. Notice I'm coming from the physical as is to the logical as is, and sometimes all the way out to the conceptual as is. Well, all of these are good, but they help us get to information that we haven't had before. Once again, you heard Jared talk about the various connectors that he has. That's what he's doing in that product, is reverse engineering those pieces. So literally, sometimes it's just a matter of pointing it to the right source. And as long as your engine has ingested something of that source before, it can be extremely fast in terms of looking at this. So reverse engineering, again here, getting all of these structured techniques in order to pull together. Okay, so how can AI help data modelers with a reverse engineering project? Well, again, this is, by the way, I gave it to the gem that I showed you before, so it's speaking as an experienced data modeler. And again, it says traditionally, reverse engineering a legacy mainframe or a cryptic ERP database gives you table names like Z, TNX, HDR, header in there, right? And you'll not have any idea that works. Well, AI can actually go in and look at these things, just like Irwin and ER Studio and other types of things, to perform the semantic analysis in here, giving you 60 to 70% coverage in there. It can do automated logical data model derivation. You can look at a physical model and it will take away all of the Oracle or Amazon specific pieces. It can extract dark logic, which is sort of business rules and triggers and things like that that are in there. Very, very problematic. It can discover relationships and self-healing lineage. So if we know where something should have come from, or guess that something should have come from there, we can actually repair the lineage characteristics of there. Again, nice little summary from the AI. Really, really good advice that it's providing here. And again, I would encourage all of you to start playing with this and learning a bit about it, because it does give us the opportunity to really understand at a much more granular level, what do we have in our systems. I would stop, by the way, and say that if you are considering buying a packaged software, that it is okay to ask the vendor. In fact, I would consider it best practices to ask the vendor for a model of their package that they're going to give you. And if they say, what's that? That's probably a sign of trouble, that they may not know as much about data modeling as perhaps they would like them to be in order to do this. If you get a logical model of a package that you're evaluating, you can put that model into the AI, because it understands this type of vocabulary that we're doing, the facts that we're dealing in context here. And when it does get that, it will actually come back and say, hey, this existing system that you have will be complemented by the package that you're considering, or will be better supported by this version of it versus this version of it. So again, best practice, if you are purchasing software or services from anywhere on the globe, require a data model of it before you sign the contract so that you can find out what actually it is going to complement in there. Moving on to our last section here, the real key for all of this, of course, is having it work well together. So we're going to put the washing machine model full up back on there, right? Again, remember, as is to be, valid or not valid, and on top of that, conceptual, logical, and physical. First, reverse engineer the existing system to understand its strengths and weaknesses. This is a process called re-engineering, sometimes called refactoring, although this is broader than refactoring goals in order to look at this. But understand the existing system. Why do you need to understand it? Well, all systems have some things that work really well and some things that don't work as well. We want to leave the things that don't work as well behind and take the things that work well with us. So we may need to go all the way to requirements. If we're not changing the requirements, we can go directly down, which means using that information to design the new system. So again, I have gone back from physical as is to logical as is, logical as is to conceptual as is, conceptual as is to conceptual to be. And the AI support for this type of an operation is absolutely exactly what you'd want it to be. If I'm not changing the requirements, I can take a shortcut and use the right-hand arrow going directly from logical as is to logical to be. Either way, we're going to use that information. If you don't use the information, there was no point in getting it in the first place and giving us that new system in the re-implementation phase. So that's what we mean correctly by re-engineering. Many people use the term much more loosely than that, and it's not very helpful. I've done in lots of companies where they're re-engineering something and it just doesn't measure up to this. Again, very easy. First, use the existing system's information to understand its strengths and weaknesses, and use that information as you're informing the new system. But so many of the time when we're doing this, we end up with just a little bit of thing here where somebody comes along and forklifts the data from the old system directly into the new system. And I've seen so many organizations suffer so badly from doing this. Again, just a really small example here, but here at the university where I am, the university lost its major donor database, and they simply started over. They lost all of the information because they couldn't figure this particular process out. Very, very sad on this. All right, so let's take it now one more piece for working together, and that's the normalization component. I find that a lot of students are not correctly remembering the way they were taught normalization in there. And they're typically taught that what you do basically is you go from a as is physical to an as is logical, and then to a to be logical back into a to be physical. And they kind of go, okay, why? And why can't I go directly across the steps? You can imagine an elevator speech or something trying to explain this to people. Well, the answer is because typically we forget the fact that while we go from physical as is to a logical as is, gaining a technology independent logical model that can be achieved with AI if you don't happen to have the right case tools in there, then we move it back over onto this side. And that sounds a little better. So I'm leaving the parts that are Oracle in the physical as is. I'm moving it into Amazon just to take a very typical set of moving around that. But that's not usually the typical reason why we do this. And so I'm going to go back through the thing again to show you really the value in this, because while what I just showed you was good, this is the better portion of it. So when I get to that technology independent model, I'm almost always doing that because I have some other logical as is data architecture components that I want to work in. And notice that I've taken the green blob and incorporated into it orange pieces as well. Only when I have that information done should I go to the to be and figure out what it could be and how much trouble it's going to be, and then denormalize as appropriate. Once again, this is not well understood. And so I think that's a very useful explanation that I've put together for folks on this. If you have trouble with that, you can come back and review this portion of the webinar until you get it, or just reach out and give us a call. You know, that's very easy. So let's talk about the data modeling process. Again, most of the time it's identify entities. Well, if I have the entities, I can also go into AI and say, what are typical attributes that would be associated with this kind of an entity? if I've set up the AI so that it has good data modeling expertise in order to do this. Find the keys for each entity. You can actually take the key design for your entire database and run it through and say, what are the potential problems that we're likely to run into? Here is my strategic goal for this particular system that we're putting together. Will this key structure support or inhibit that particular strategy? Draw a rough map of the entity relationships around here, but you don't have to rely on yourself. You can go into the AI and say, hey, I want you to tell me what things should be related to other things. It may go to Len Silverstone's book and grab the information out of there, no problem. Once again, if you've purchased it, that's great as well. Next step is you want to add the attributes across all of these, working always from our single integrated data dictionary. There's just no point in not doing that kind of an exercise because otherwise you'll end up with something that happened here last night. I was asking one of my student teams what their name was because they get to name their teams, and they said Team One. And I said, oh, well, that's pretty boring. And they said, no, WON. Oh, thank you very much. That was actually quite a clever little name in there. Eventually, your model should settle down, but it should evolve based on your understanding at first. And so that little bit of evolution that I just showed there should eventually peak, get to diminishing returns, and stabilize around your model as you do that. When we're looking at these things, we may also add additional structures that can either be suggested by the AI or not. Again, you'd be surprised if you start to work with these things. They actually do try to come up with pieces of insight. So I had an AI the other day talking to me about a thing that we were doing in this, and it came back and said, hey, this story that you just told would be a really good piece to include in your new book on data debt. Ha! What a wonderful suggestion. It actually was a very good one. So let's take a look again of why we're doing this. The reason we're locked in this room is to understand the formal relationship between a soda and a customer. Okay, now if you think of it as soda and customer, that's interesting, but it doesn't actually help. You've probably noticed that the soda companies are now allowing you to mix your own drinks. Why do you think they're doing that? Because they want your data. They want to know what flavors you want to have so they can try and anticipate them and put them out on a product that you will then purchase. Again, different components in here as far as that goes. The goal is to walk out the door with a data model describing this relationship. Here's another one. What are the different characteristics? Excuse me. What are the characteristics that differ between our hospital beds? Again, if our bed is going to be the primary way that we're going to track patients, maybe I want to be a little bit more careful about that. Again, an RFID on a bed wasn't a good idea. GPS on a bed, okay, but there's actually other ways we can do it that are less expensive and less invasive all the way around on that. Third example here, could our systems handle the following business rule tomorrow? What? Well, the question is job sharing permitted? Once again, you can look and see, oh, an employee, according to our current systems, has exactly one position, and the position can be filled by 0 or 1 employees. So the answer is not currently. But if we go back and re-wicker this and say, oh, okay, maybe what we'll do is we'll put in a position can be filled by 1 or more employees, we might have the outcome that we're looking to obtain as we look at this. So as another aspect of the modeling here that you'll see, it should evolve over time. You should be collecting less evidence and doing less analysis as you move from your preliminary activities to your modeling cycles to your wrap up in there. Similarly, your analysis should increase correspondingly as you go through that. If you're not seeing that pattern, you're not having enough understanding. And once again, AI is a tremendously powerful accelerant to do this. Our coordination requirements will decline over time in there, and we'll be doing increasing amounts of target system analysis. And finally, more validation and less refinement as we go through the entire process. So this is just ways in which all of these things can go through and evolve as we're looking at these. Finally, Do not start off from scratch. There is one version of Len's data model resource book down here on the right. And like I said, I would absolutely recommend these are all really good books about data models and patterns and things like that to give you a good set of Lego starter pieces to get started with things. And again, the AI knows about these particular pieces. So we spent really the last 50 minutes here looking at data models. Why do we need them? How can they be used? And there are some challenges to get them increasingly used because people never really understood what they were doing, but the AI does. Engineering and architecture then are the same side of the data coin. They must operate on standard shared data of known quality in order to do this. And from the top, we're looking at forward engineering with our goal of building, but we can just as easily and probably more often should go from the bottom up, reverse engineering our existing systems with the goal of understanding them so that we can allow them to work together in a re-engineering context. On this, finally, if we don't stop and try to become more simple, our designs are simple, there's nothing that will happen that will make them that way automatically. So we want to do things better that way. So we're headed towards our takeaways. And as we're doing that, I'll just give you quick things. Both data architecture and data models are made more useful by each other. The power is derived from their interdependence, and the models are the primary means of achieving specific shared understanding of data challenges. They are literally the pages that intersect the asset and the organizational response. Data architecture is the sum of data models. Coverage is rarely complete. Data models are documentation and the currency for data coordination. As I mentioned earlier, the CIO that I knew very well did not understand it, but he understood it was valuable. And so he was absolutely willing to fund the kinds of activities that were being done. You can also verify integration and mandate input to any type of data systems evolution. If you're going into AI, we didn't talk specifically about that, but if you're going into AI, a data model is a necessary component of that. Actually, the next webinar will dive into that topic quite a bit in there. The problem is we teach forward engineering in schools, so most people don't understand the reverse engineering is an equally important part to come out of this. We're going to finish off here with just a piece out of the Washington government here. I've worked in that structure for a lot of time, and the Office of Personnel Management came out with something that I guarantee you is not going to have any data modeling involved, although it absolutely should. The Office of Personnel Management is going to do a project that was very similar to what I did with the DoD. My first task for the Department of Defense was to consolidate 37 systems into one that all paid people. Well, they've decided they're going to get 100 outdated duplicative federal information systems because it sounds like a good idea, but I can tell you the data modeling requirements for a system that supports firefighters and warfighters is very different from the data modeling that is required in order to support other types of human capital. Might be a forest ranger or just a knowledge worker working in the bowels of DLA to keep our warfighters supplied with beans and bullets. This is an insane waste in order to do this and makes absolutely no sense, but that never stopped the government from doing things crazy before on that. So we are at 3 o'clock and it's time to invite Jason and Shannon back on and see what sort of questions you guys have.
Thank you to both of you so much for this great presentation. If you have questions for Peter and or Jared, please feel free to put them in the Q&A panel and I'll be reading questions from there. And just to answer the most commonly asked questions, just a reminder, I will send a follow-up email to all registrants with links to the slides, links to the recording, and anything else requested by end of day Thursday for this webinar. So diving in here, we got questions coming in. How do you break through the fear over release of private protected data? My organization has SSA, FTI, and other heavily regulated data that are core to our systems. Nobody wants the risk of AI in the org.
Absolutely great question. Before I got laid off by the Doge people, I was working in a secure information facility, the SCIF, if you will. And they actually had access to AI on the other side of it. So it is possible to bring in. It tends not to be the absolute latest and greatest. We would call that the bleeding technology, but in fact, it's really important to understand that almost all organizations have figured out some way of getting access to this at a leading edge technology. Jared, what's your experience been? Have you seen customers that are having trouble with that and concerns about it? It is a valid concern.
Yeah, so I think it is a valid concern. One of the ways that we see customers dealing with this right now is running local models. And I know that there's a pretty large infrastructure cost to be able to do that effectively when it comes to, acquiring chips, RAM and GPUs in order to have an effective local model running. But when the model itself is running within the four walls of business, it really, I mean, you don't even have to ask the question of where the data is going, who's seeing it, because you could air gap that machine even if you needed to.
It's interesting. I'm working with a local government right here in Richmond, and I asked them, could I have a copy of their data governance policy so I could toss them into an AI? And they were like, we're going to have to run that by legal. And I said, no, you don't. It's FOIA, right? If it's something can be gotten out. But you're right. There's absolutely a lot of concern here. And Jared, you mentioned something in your talk here that I found was good too, which was the six or more data sources. How are you going to go through and do that kind of an integration exercise without actually having access to the metadata that's there? And if you've got access to the metadata, you can be pretty sure it's gotten hoovered up by an AI somewhere in there as well. Any thoughts on that?
Yeah, I mean, just how do you build an accurate picture of metadata without access to the data? Am I driving at the right question?
You are.
Yeah, so I think it comes down to a lot of what you've talked about here is you have to define that data model. You may have to provide that metadata using subject matter expertise and not giving the AI uh, access to that data directly. And then from there, you can choose what gets exposed to AI by that data model. You know that there are certain fields or attributes within your data set that are private or that need to be kept secure. You just don't include those in the data model. And then you make sure that the access layer between the AI and the data set itself also doesn't include that restricted or private or controlled information.
Absolutely. I've seen also some companies try to use their InfoSec infrastructure to control data access to AI, which is an interesting piece. I'm actually going to a conference in 2 days where that's going to be one of the topics that the group is going to look at. So the idea here is that you absolutely declare and have the AI go around, find your PII and all the other things that you don't really want to share. And then you can build access rules not just to people, but also to the AI and treat it as just another destination for these things. And that has actually got some companies doing very, very nice progress on that. Great question. Thanks for starting us off with that.
Great. So, do you upload a PDF of the data model to the AI?
The uh, I can't speak for all the AIs, but the ones that I'm working with do understand a data model when it's uploaded as an image. Better still, and we're doing some work with a local case tool vendor on this. The data models are also well understood in their native format as well. And Jared, you probably have already done all of this engineering because you need to have one of each type to connect up to your hub in order to do that. What is your experience in that area?
Yeah, so the way that we do it, so I'll speak to the way that we do it, and then I think we can step one step outside of that. What CData does is we present a relational model of all of the services that we connect to. So we've been doing SQL access to data through database connectivity standards for years. And if I get too weedy, feel free to cut me off. But the idea is that instead of having to know what a Salesforce account is or what a Jira issue is, the LLM through the data layer that we present just thinks that it's talking to a database. Because it thinks it's talking to a database, LLMs have been trained on databases, how to navigate databases, how to find relationships within databases for years. And so what we present is the ability for the LLM to kind of explore the data set itself to look for those relationships based on its own understanding of how databases work. And then it can even use its training model to reverse engineer things. One of the things that we've seen specifically is, and this is outside of our system, this is just the LLMs themselves, is anybody that has worked with SAP knows that some of the table names and view names, column
MANDT.
names. Yeah, they're very, very esoteric. If you try to read them in English, you have no idea what's going on. I can open SAP documentation and maybe get there eventually, but somewhere in there, the SAP data model has been a part of the training data set for the most of the LLMs that I have seen try to touch SAP. And so the LLM itself does its own reverse engineering of that. So, there's a lot going on there. And then I think to come back and to step outside of necessarily what CData itself does with that relational model, I think that the models themselves are getting better and better at uh, understanding what they're looking at when they look at any given thing. And a lot of that they take from the context of the service or the system that they're connecting to. They connect to a Snowflake data warehouse. They know how to navigate a Snowflake data warehouse. They have access to Snowflake documentation. They're connecting to HubSpot or they're connecting to governance documents. They're connecting to legal cases. The better these models get, the more trained they are, the better they are at kind of inferring their own data model on the fly and then being able to construct the right question and get value and get the right answers out of the data.
Absolutely. Mention the question also asked about running stuff on device, and the devices are getting much, much better. So there's a Anywhere LLM that runs on native on a Macintosh. I think that's cross-platform. There are several others that you can do where you don't actually need to go out and buy the big GPUs and things, but you trade off time, of course, when you do that. But if you've got things that you can actually put on sort of a background processor that doesn't kill your CPU. You can actually have these things running literally on your friend. Todd Harbor, who is the fellow I've written 5 books with on this, has done some really amazing things on that, and he's not buying anything other than commercial off-the-shelf software, and keeping his stuff completely air-gapped from the rest of the world, and at the same time getting really, really good results out of this. So I love spending time with him because he shows me something new every time. Again, great question. Thank you for that. Get to our next one, Shannon.
And only 5 books?
Todd's written 5 books with me. Yeah.
Just teasing you. Is it, I know you've written 12, so is it a good idea to have an organizational data modeling standards? Can AI help us understand to what extent we have complied with our standards?
Oh my goodness. And not just that, let me take to the easy part, right? Nobody likes to submit something to be QA'd, right? So do it yourself, right? You can actually set it up so that you don't have to have people submit things that are incorrect. You can run it through this. Again, I'm putting the screen here with the gem up. Okay, that's again very technical portion of Gemini, but what it doing, you can tell it that you only want to have this type of model, that you want to do the modeling to optimize for speed as opposed to risk, again, different ways of doing it. You can make these instructions here very, very detailed. And then when you start asking questions about it, it starts to remember this. And as I said, it tries to delight you with some insights in there. Sometimes they're absolutely correct and sometimes they're absolutely wonky in there. But it is an interesting component. Jared, any thoughts on that?
Ah, um, I don't know that I have much more to add.
Okay.
Building out expertise, taking your expertise that you have built out as an organization or as an individual, and trying to train a gem or a custom GPT or a Claude project or whatever the case is to build in those guardrails and then continue to refine that, I think becomes one of the best ways. And it would be, I think, a good way to help you uh, refine any data models that you build is if you build a data modeling gem or GPT.
I think the question is a very valid one. Again, in the old days, we used to give all the students a case tool and show them how to do DFDs, and the case tool would come back and tell you whether the DFD was modeled and was balanced in that, because they had that kind of expertise built into them before. The problem is now most students don't have access to a case tool while they're going through school, and so consequently, you're really relying on the AI to do this, which is not, like I said, not a bad habit to get into. So if you've got an organizational standard that says, hey, these are the things that we're going to put in place, you can actually say, hey, I want you to take my model and now make it conform, with whether it's just documentation or whether it's language. Make sure that I've got an entry in the data dictionary for every entity that I have in there and every attribute if you're going to get that detailed about it. So it's really limited by your imagination and by what the um, um, organizational rules are that allow you to do this. And again, I was in a highly classified environment, but I was still able to use these types of tools to get access to these things in there. So these things are only going to get better. They're not going to get worse. Don't worry, somebody will find a way to mess up something somewhere, but overall, people are trying to do this and realizing there is absolutely fantastic value to be gained from these.
Perfect. Thank you. And this next question came in a couple times. So they say that star schema is dead. What is your take on that?
Wow, star schema is dead. What else have we predicted the demise of, Shannon, over the years?
Metadata.
Yeah, exactly. We've
Like
heard
data
that one a
modeling.
couple
Yeah,
times.
data modeling
Yeah.
is dead. That was going around for a while. Yeah.
Jared, jump in. What do you think? So you
Yeah,
seeing that?
yeah. So yeah, I mean, kill it, right? It's done. Forget it. We don't need it anymore, right? Uh, Thankfully, that is not the case. I mean, so the star schema, right? It lets you optimize that query performance. It's based on your understanding of your data set and breaking things down in a way that makes it easy for a human to consume. And in my line of work, what we're really targeting is the ability to do analytics and reporting, to build dashboards and visualizations, right? It gives you that clean dimensional model that humans need to be able to navigate through things. So what I will say is in the world of AI, I think the star schema still lives because having that star schema around is just going to make the AI faster at whatever data related task you're trying to make it do. It's not necessary. I think without it, the AI is powerful enough, the LLMs are powerful enough to be able to, like I've said but previously, to explore an undocumented data set and start to infer relationships between all of the data systems, whether they're within the same service or not, whether they're within the same database or not. But having that star schema, building it out, is going to help all of your human users who are trying to do very human things, but also help that AI to do all of the long running, arduous, drudgerous tasks that it wants to perform, that you want it to perform. It's just going to make that your results happen faster and probably in a more deterministic way than if you just throw the AI at something that's undocumented or unmodeled.
Super. And I'm throwing, this is obviously not a star schema up there, but I'm throwing the same concept up, which is what you guys do. Connecting everything up into one simplified data source means that you're running both your BI, your analytics, and your AI through the same governance framework is an absolutely no-brainer. And yet it's so often I see people, oh no, we're doing this for this and we're doing this for this. And it's like, no, 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 pick one, get good at it, and try to simplify your world because the world is complicated enough as it is. Something else I'll say in defense of the star schema, not arguing that it should remain around, but I think it's going to, it's because it's very understandable. When I show you this picture, or if I showed you a star schema on this, you would look at it and go, yep, I know exactly what that is. And having that type of communication means you've got a good jumping off place for communication. You may decide that ultimately you need to tweak it or something else in order to come up with things. But I don't think I'm going to bet against Snowflake, I guess, is if I were in the marketplace, wouldn't be doing that just yet. I think there's plenty of life in it still.
Thank you. So how do you handle business customers that AI generate an application and want to have it re-engineered in an enterprise architecture?
Wow. Let me make sure I understand the thing. So a customer wants to re-engineer
How do you
a set
handle
of
business
systems.
customers, yeah, that AI generate an application uh, for and want to have it re-engineered in an enterprise architecture? So you've generated an AI application for them, and then the customer wants to have it re-engineered in an enterprise architecture.
Jared, you want to take that one? I'm
Yeah, I
kind
was
of
gonna say,
drawn.
so that's tough.
Yeah.
And
Good
so,
question.
yeah, it's a great question. And it's I think it's timely, right? We're living in a world where anybody can open a terminal with access to a folder and say, build me an app that does day trading.
Vibe coding, right?
Yeah, exactly. So this is one of the things that my team and I we're actually learning to do better. I am not a Rust expert. I am not a TypeScript expert. I'm not a LangChain expert by any stretch of the imagination, but LLMs are. But I think what you run into is the value of that subject matter expertise. So we're going to move a little bit out of, I think, the idea of data modeling and more into just the conceptual engineering. Engineering is a concept in that I think you still need some sort of process, stepwise, uh, goal-oriented method for coaching an LLM into building something. I think what's great is that if you have this business user, business customer that has come in and says, "Hey, I built this app. Let's slot it into, our SaaS offering, or let's package it up for commercialization." I think you can still have a product team or a data team or some combination thereof that takes what has been built and then runs it through the LLM again through the lens of re-engineering it for that enterprise architecture. And that's something that, we see happen even internally is we're a software company. We write code that does work. And so now you've got junior engineers who can produce, larger pieces of an application or whole applications. And then it passes through a senior engineer who doesn't have to go line by line anymore, but can run it through an LLM, have the LLM pick it apart, and then go in and vet all of that. And now I'm thinking that you could do the same thing with a data expert, a data engineer, right? I'm a junior data engineer. Here's this data model that I have constructed with the help of an LLM. Let's put it into production. Well, now a senior data engineer doesn't have to go row by row, grid by grid, you know, uh, connection by connection to understand it. They can also pass it through that LLM.
I would also say that many times organizations overcomplicate their process. Even though these instructions here are very simple, again, first reverse engineer the existing system to understand its strengths and weaknesses, right? Sometimes it's the secrets. And then second, use that information. And I find companies have a lot of problems getting there. So if you're at this other level, consider yourself very fortunate and above average in maturity. Would you agree with that, Jared?
Yeah, I think that tracks.
That's good. And then you can use these types of systems and tips and tricks we showed you here to build the case for it as far as, well, it's great that you've got it and it works. I'll give you an example that I'm very familiar with and thoroughly enamored with. Starbucks is a $36 billion a year corporation. One third of its revenue comes in through their app, and the app used to suck so bad that it was driving customers away. That's clearly something that needed to be re-engineered, and I'm not sure because I'm not a real good Starbucks customer, not being a coffee person. So I haven't gotten in to see it anyway. But when I ask the students and my colleagues and all, they say, yeah, it's a little bit better, but it's definitely not better. You don't want to put a 12 billion, excuse me, yeah, $12 billion a year resource under, in jeopardy because you can't get the re-engineering of the application right. I mean, it's silly, right?
Right.
Sorry, I didn't mean to make you agree with me, Jared. That's what I have in mind.
No, no, it makes sense.
Yeah. All right, Shannon, how are we doing?
Doing well. And we've got about 9 minutes left, so we've got plenty of time for a few more questions here.
Super.
So, do you do any of you read the data catalog, most of this content, as well as data model repository?
So are you asking if you're trying to do reverse engineering, you haven't figured out how to reverse engineer the Oracle or whatever catalog that you have? Yeah, you're wasting a lot more time. And all of those things are databases, therefore they are reversible, right? I think that's what the question was.
think so, but David, if you want to uh, clarify
Sorry,
a bit
Jared.
more on that.
Yeah. Jared, any thoughts on that?
Yeah, so I mean, if I'm reading it, where you're trying to treat the data catalog as the source of truth, um, the a data model repository is going to give you that technical schema and the relationships that exist within the data catalog. But I mean, I think I'm making some assumptions on what the question is about to arrive at that
I
answer.
will say that is something that you guys have clearly done with your technology is that you go in and you read, the SAP catalog once and you've got what it looks like. There was an old product called Sapphire. Shannon may remember that from a couple of years back that would go in and tell you all the customizations that have been done to your SAP environment by comparing it against a straight out of the box base system and looking at it this way. So yes, going in and finding ways to read where you're storing formally metadata. And by the way, the catalogs, right, for these databases are updated automatically. So you have a lot less data quality errors that go in there that are inserted by human processes and things like that. So it's a really good source. Another great place to go and do the same type of an operation is look at your ETLs. There's so much good metadata buried in your ETL streams that you have that once again, I would just be really reticent to try to say, look, if we haven't understood those yet, we don't have a full picture of what's going on enterprise wide. Great question, though, fairly advanced.
Yeah,
Yeah,
well,
yeah. David came back
yeah,
with a follow-up.
Oh, good.
exactly. Yeah, and the question there is metadata content to get all the details for relationships, definitions, etc. Data catalog will orchestrate across all source metadata, meta content.
Some catalogs do better jobs of maintaining it than others. Anybody remember how to use a VSAM catalog out there in the old days? I know, Jared, you're not that old, but I actually had a customer that ran into a bunch of VSAM files the other day and couldn't figure out how to get data out of them.
That's you have given me research to do now, Peter.
There you go. VSAM, good old IBM Virtual Sequential Access Method is what it was called.
Okay,
It was a sort of the access database of the IBM world back in those
okay,
days.
got it. Yeah, but yeah, I'll agree with you there. Yeah, the data catalog using either something that you've written yourself or adopting a platform or a service to orchestrate across the meta content. Some are better than others, but a solid answer to that question of managing
I,
metadata across disparate
I would go a
sources.
step further too, and that's to say that if you do have a custom piece that somebody isn't familiar with, maybe you've grown it yourself. Again, no problems with that. You probably also have an expert in your organization that either put it together or figured out that it was also going to be a good source of golden truth and might need an access method for it as well. So, when I was traveling for the Defense Department, I would walk into these places and, you'd make it tell people what was going to happen and how the systems were going to evolve and all the rest of these things. There'd always be somebody in the back of the room standing there with their arms crossed going, let's see if this guy can figure out that all the metadata that he needs is actually in the catalog that I built 20 years ago. And sure enough, like I said, every organization I've gone in that's had a custom one, they've had somebody around who just has to be there because they know how to get access to that good set of metadata that's there. Again, really good. Good. I should probably add a couple components to that to the presentation here. Maybe I can get it done by next month. Hey,
Ideas, I love it. Uh, so we got time for a couple more questions here. So where and how do you model PI data and apply it across orchestration layer all the way to the semantics layer?
where do you
So that's
model PI data? Yeah, you need to model it everywhere, right? I mean, come on. You're not just going to put a big cloak over it and say it's PII and we can't do anything with it. So it's part of the modeling. Jared, do you agree with that?
Yeah, so I think you do it. You've got this image up. I think the best place to do it is at the hub level. So
Hmm.
you'd spoken before, right? The hub is the one place where whether you're doing software development or business intelligence, analytics, reporting, ETL, or you're letting AI touch the data, that hub is the one point of contact for that contains all of your definitions, your complete data model. And I think it's at that point that you start there. And that way you're sure that PII never leaves the system that it's not supposed to leave, that you've got this kind of semantic layer or connectivity layer that enforces whatever PII mandates you've got in place for your organization everywhere.
And what Jared just described for you all there is exactly the same process of understanding the catalog, right, for your database. So let's just say that application 5 in this instance was a database with a family of programs around it, but it had been custom built, and you're not quite sure how to get all the data out of it. Well, again, get that reverse engineering catalog, move that information into the hub. And then if you remember some of the suggestions from the AI were, hey, it can look for things out there and say, maybe this is PII and you don't know it's out there. And you can give it a task of finding PII that I haven't already identified as PII. Oh, one more piece for all this too. We do have some newer tools that are going in place, things like tags and stuff like that that we can put in place that can adjunct, additionally amplify and be an additional level of control or guidance at least around that type of thing.
Right, thank you. All right, one more question here. So are relational databases better suited for LLM ingestion versus NoSQL database or graph databases? Pros versus cons?
We're doing some very cool things with graph databases and looking at how the ability to walk into a large government organization, as the government for a foreign country, can actually chop up into different sections, subject areas, and we can track data that goes back and forth across the others. But I'm hearing an either or choice there. Why don't we just concentrate on managing the metadata well, and then if we need to, we ingest it into a quick relational piece, or if we need to, we can ingest it just as easily into a graph database because that same core set of data is going to be useful in both of those applications for different purposes.
Yeah,
Jared, any thoughts on that?
yeah, I was gonna say I like that answer. The idea that the understanding what the data is probably the most important first step, and then you can configure it or surface it in the way that makes the most sense. Because I don't think it is an either or, especially in today's era where you've got, I saw somebody in the chat saying they've got 500 applications that they're working with. So some of those applications, the relationships between the objects are going to be just as important, if not more important, than the objects themselves. And that's where a graph database or presenting something as if it's a graph database makes a lot more sense than trying to force it into a relational model. I think the one advantage of, standard relational database model is they've been around for forever. And so there's a lot of mature tooling and well understood schemas when it comes to working with those. But I mean, graph databases have been around, different other ways. You've got NoSQL, you've got completely unstructured data that you need to be able to work with. So it gets back to your point, Peter, understanding the metadata about the data first and then deciding what's important about the data set next defines how you provide that access. But as far as for LLMs, I think at the end of the day, they don't really care as long as you're telling them the real question that you want answered.
And how to go about getting the answer. That's the other part. Always good to give both sets of instructions.
Indeed. Well, that is brings us to the end of our time. So many great
Super
questions we
session.
haven't had a chance to get to even. But thank you both so much for these great presentations and this great discussion.
We
And thanks,
appreciate it.
yeah, thank you. And thanks to CData for sponsoring today's webinar and helping make these webinars happen. We really appreciate it. And thanks for joining us today, Jared. And thanks to all of our attendees for being so engaged in everything we do. Just a reminder, I will send you a follow-up email by end of day Thursday with links to the slides and links to the recording. Hope you all have a great day. Thank you all. Thanks,
Join us
Peter.
for
Thanks, Jared.
other upcoming ones. And Shannon, thanks as always. Cheers, everybody.
Cheers.
Thanks, Shannon. Thanks, Peter.
Thank you, Jared. Real pleasure.